told you that pi, the most famous number in human history, the universal constant of the circle, doesn't actually need a circle to exist.
Which is, I mean, that's just wild to even think
All
about.
right, just think about that for a second. Every textbook you've ever read, every poster in like a middle school math classroom, it defines pi by drawing a circle.
Yeah, they point to the diameter, point to the circumference.
Exactly. We are taught that the shape completely dictates the number, but what if that entire visual is, well, entirely backward?
It's a massive disruption of a fundamental assumption we all have.
Oh, totally.
We naturally view mathematics as this unshakable architecture. You look at an equation and it feels objective. It feels solid.
Like it's an absolute truth.
Right. But when you start to pull at the threads of how those equations are constructed, and more importantly, how they're taught to us, that solid architecture starts to look, a bit translucent.
Welcome to today's deep dive. We have an incredibly unique, highly rebellious source text for you to explore today.
Rebellious is definitely the right word for this one.
It really is. It's an actual translated transcript of a conversation between a coder and an artificial intelligence. And this is dated March 30th, 2026.
Right.
So the coder brings this custom Python script into the chat. They proudly call it the Grok pi formula, and its entire purpose is simply to calculate the value of pi.
But we should be clear right off the bat. Our mission today isn't to just do some standard dry code review.
Oh, absolutely not. No, we are looking at a document that starts as like a simple 1 million step coding experiment, but it rapidly evolves into this systematic dismantling of mathematical smokescreens.
Yeah, it exposes this fascinating layer of pedagogical deception. Basically, how the way we are taught math often obscures the raw reality of what math actually is.
And I want to promise you, the listener, right now, you do not need an advanced math degree to follow this.
No calculators required.
Leave the graphing calculator in the drawer. No pop quizzes on calculus today. We're going after a massive aha moment regarding how we think about geometry and ultimately, how we perceive reality itself.
Sounds ambitious, but the source text really goes there.
Okay, let's unpack this. The coder drops this Python script into the AI chat. It is elegantly simple. I'm talking less than 10 lines of code.
Very clean.
Yeah, essentially it's designed to trace a perfect unit circle in the complex mathematical plane. And it does this using a very famous mathematical function involving Euler's number, usually written as an e raised to an imaginary power.
Right, the whole e to the I theta thing.
Yeah.
But to understand what the code is doing mechanically, we really have to look past those symbols and visualize the action itself.
Okay, paint that picture for us.
So the script calculates the distance around a curve. It does this by taking the magnitude of the derivative of that exponential function.
Which sounds complicated, but
without getting bogged down in the textbook definition of a derivative, the critical takeaway here is just the speed, the magnitude, the speed at which this virtual pen is drawing the curve is exactly 1.
oh, okay, so it's constant.
Exactly. It's a constant, unwavering speed of 1 at every single microscopic point along that journey.
So because the speed is a constant 1, the code can use a technique called a Riemann sum.
Right.
Over exactly 1 million discrete steps, the code just adds up tiny microscopic slices of the arc. I think mathematicians call these tiny slices delta theta.
Yeah, delta theta. Just a tiny change in the angle.
So by adding up all 1 million of those tiny slices, it calculates the total circumference of the circle. Then it just divides that total by 2, and it spits out an approximation of pi.
And in this specific run from our source text, the code outputs 3.141595795185588.
Wow. Very specific.
It's a fundamentally sound method of numerical integration, but the abstraction makes it sound way more complex than it actually is.
Well, let me put a physical visual on this mechanic for you, the listener, because it's crucial for where this deep dive is going.
I love a good analogy.
Imagine you're standing on the edge of a massive, perfectly circular running track. Normally, if someone told you to find the total distance around that track, you'd try to find the exact center point, lay down a giant measuring tape to get the diameter, and then multiply it by pi.
Right. That's top-down geometry. It's how we're taught to do it.
Exactly. But this code doesn't do that at all. Instead, imagine you just strap a digital pedometer to your hip, and you just start walking.
I like that. Just step by step.
Yeah. You took exactly 1 million tiny, identically sized steps all the way around the edge of the track. You aren't doing complex geometry. You don't even care where the center of the track is.
You're simply accumulating distance.
Yes. Adding one tiny unit of movement to the next until you arrive right back where you started.
And, the AI in the transcript is thoroughly impressed by this exact approach. It actually praises the coder for independently arriving at this method.
Oh, really? It validates it.
Yeah, it completely validates that this isn't just some clever hack. It's mathematically rigorous. It works. But, as with any discrete computational process, it leaves a very faint footprint.
A footprint? What do you mean?
Well, the AI highlights a specific detail in the output. The absolute error of this calculation compared to the true infinite value of pi is exactly 3.14 times 10 to the negative 6th power.
Which is incredibly tiny. I mean, we're talking about an error hiding way, way out in the decimal places.
Most people would just call that a rounding error and move on.
For sure, I would.
But the AI zeroes right in on the mechanics of that error. It explains to the coder that this minuscule discrepancy exists entirely because of the discrete, step-by-step nature of the code itself.
Because it's not a perfect curve, it's a million tiny straight lines.
Exactly. Specifically, the coder used a standard Python function called mp.linspace to generate the steps. And that specific function naturally includes the final endpoint in its calculation, which throws the microscopic step size off by just a hair. And because it's an AI analyzing code, it immediately treats this as like a technical puzzle to be optimized.
Or wants to fix it.
Oh, it starts offering up all these textbook upgrades.
Yeah.
It tells the coder they could fix this tiny error by using np.traps to do trapezoidal integration, or they could apply Simpson's rule for a smoother curve.
But fixing a tiny rounding error kind of misses the forest for the trees here, doesn't it?
Completely.
Yeah, the coder isn't actually interested in debugging a millionth of a decimal imperfection, because seeing the mechanics of the circle laid absolutely bare like this, seeing those 1 million tiny individual steps simply adding up to a total distance, it causes the coder to look at their own equation and spot something highly suspicious.
Yeah, this is the turning point.
The code works perfectly, but looking at this step-by-step physical process, you have to ask, why do we even need Euler's number here in the first place?
Yeah.
And this is where our source material shifts dramatically. We move out of a pure coding exercise and step right into a razor-sharp mathematical critique.
The coder looks past the function itself and focuses entirely on the structure of the mathematical language being used. They send a single paradigm-shifting message back to the AI.
What do they say?
They say, I think the number E there is completely superfluous.
And the AI instantly validates this realization. The AI completely agrees. The complex exponential, Euler's number E raised to the imaginary power of I times theta is completely mathematically unnecessary for this calculation.
It really is. Think about your pedometer analogy.
Yeah. The simple arc length, that tiny physical step we call delta theta, gives you the exact same result without ever once touching complex numbers or imaginary numbers or exponentials.
Here's where it gets really interesting. If Euler's number, this incredibly famous foundational mathematical constant, isn't actually needed to find pi in this formula, why is it plastered all over the textbooks?
Good question.
Why did the coder instinctively use it in their first draft of the code to draw a simple circle?
To me, using the complex mathematical plane and imaginary numbers to measure the simple act of walking around a circle, it feels like renting a massive diesel-powered industrial crane just to lift a coffee cup off your desk.
That's a great way to put it.
I mean, sure, the crane works, the cup gets lifted, but it is massive, expensive, confusing overkill for a job that just requires you to use your hand.
What's fascinating here is that the AI essentially calls out that crane as an illusion. It introduces this incredibly potent phrase, stylistic decoration.
Stylistic decoration.
Yeah. In the realm of advanced mathematics like quantum physics or fluid dynamics, the complex plane is undeniably elegant. It's deeply useful. But if your goal is simply to calculate pi by numerically walking around a circle,
It's just a trick.
it's an unnecessary layer of academic varnish. It masks the incredibly simple, fundamental physical truth of the calculation.
The stylistic decoration. That is such a polite, beautifully diplomatic way for an artificial intelligence to describe centuries of rigid, deeply entrenched mathematical tradition.
It highlights a crucial vulnerability in how human knowledge is passed down, honestly.
Impressive.
Well, we have this habit of teaching the most complex, sophisticated version of a tool, even when a simpler one is not only sufficient, but actually reveals the underlying reality much more clearly. We teach students how to operate the crane, and we completely forget to tell them they have hands.
Wow. Yeah. Realizing that this foundational number E is just Stylistic decoration pushes our coder entirely over the edge.
I get fired up.
They really do. They go from observing a slight coding inefficiency to making a much bolder, almost scandalous claim about the way mathematical concepts are fed to learners like you and me. The source material gets intensely critical right here.
It does.
The coder flat out calls the use of E as a universal marker a scam, a fraud.
Calling one of the most revered foundations of mathematics a scam is an aggressive move.
Highly rebellious.
Right. The coder points directly to the core algebraic rule for squaring a complex number. You know, that classic identity where you take x plus iy, square the whole thing, and get x squared minus y squared plus i2xy.
Yeah, that one.
But we don't even need to visualize the algebra itself because the coder's critique isn't really about the numbers on the page. It's about the physical mechanism those numbers represent.
Right. Let's break down why they're calling it a scam. On paper, that algebraic rule looks perfectly fine. It's just moving symbols around. But physically, what that equation actually does when you map it out is force a rotation.
It builds the curve artificially.
Exactly. Using imaginary numbers as a sort of hidden algebraic motor. Imagine you are driving a car and you physically lock the steering wheel at a slight angle.
Right.
If you hit the gas, the car drives forward and naturally traces a perfect circle on the pavement. That's pure physical reality. The steps dictate the shape.
Makes sense.
But the complex algebra is like putting a massive invisible computer system inside the car that constantly recalculates your GPS coordinates using imaginary numbers just to tell the wheels to turn a fraction of a degree.
Yeah, it's totally backward.
The coder is basically saying, we are using this massive hidden algebraic motor to force this curve, and then acting surprised when we end up with a circle.
The AI's response to this scam accusation is masterful, though.
Yeah.
It doesn't just blindly agree with the coder's outrage, and it doesn't shut the coder down to defend the math establishment either.
It's very impartial.
It dissects the accusation. It starts by clarifying that the formula itself isn't a lie. Algebraically, it is true. If you expand the brackets using the strict rules of algebra, the math is flawless. 1 plus 1 still equals 2.
Right. The gears turn correctly. The crane lifts the cup.
But, and this is the critical distinction the AI makes pedagogically, it is an illusion. The AI literally uses the phrase smokescreen.
A smokescreen.
Yeah. It agrees with the coder that the way this math is taught forces a false narrative. It forces a narrative that the complex numbers explain the circle. We teach students that the complex math is the engine generating the shape.
When in reality, the causality is entirely inverted.
Exactly.
I want to advocate for you, the listener, right here, because this brings us back to the high school classroom experience. Doesn't this mean we're actively confusing students?
Oh, without a doubt.
The source text is basically saying we take a simple, intuitive, physical concept like arc length, just locking the steering wheel and driving, or putting on a pedometer and walking the track, and we intentionally describe it with this dense, complex, alien language of imaginary numbers.
And we wonder why kids hate math.
Right.
Yeah.
We hand a teenager an intimidating equation filled with E and I. We tell them to memorize it, and we say, this creates a circle. Are we creating a false sense of depth just to make math look harder than it is?
This raises an important question about the purpose of education. Are we teaching understanding, or are we teaching obedience to complexity?
That is a brilliant way to phrase it.
Well, the AI validates your frustration exactly. It tells the coder, you aren't feeling an algebraic deception, you are feeling a forced architectural narrative. It is an obfuscation of perception.
Obfuscation of perception.
In classrooms, we are taught to look at the complex symbols. We are taught to revere the elegant equations on the whiteboard rather than looking at the simple reality of the physical shape. We are graded on how well we manipulate the complex language, completely divorced from the physical reality that language is clumsily attempting to describe.
We're staring at the intricate, incredibly complex steel scaffolding, and we are entirely ignoring the building itself. We're grading students on their ability to build scaffolding around an empty lot.
And when you finally realize that the scaffolding isn't actually holding the building up, when you realize that the building, the simple geometry of a step, stands perfectly fine on its own, it completely shatters how you view every other structure in the intellectual city.
It really makes you question everything.
You start to wonder what else is just a facade of complexity holding itself up.
But here is the truly beautiful, redemptive part of this source material. If we completely strip away this scam, if we go back into that original Python script and brutally delete the E, delete the I, and remove all the complex algebra entirely, we aren't left with nothing.
The script doesn't break.
No, the universe doesn't collapse. Instead, as the text beautifully reveals, when you clear away the smoke screen, you are left with a radical, breathtaking new way to define pi itself.
We reach the absolute core of the onion.
Yeah.
The coder strips the formula down to its absolute purest, bare-bones form. No E, no I, no squares or roots. The code just becomes a pure, discrete sum of steps.
Just a sum.
It simply calculates half of the sum of 1 times delta theta. That's it. Walk the track, count the individual steps, multiply by 1, and divide by 2.
So what does this all mean if we connect this to the bigger picture? What does that actually mean for our understanding of reality?
The ultimate conclusion of the source text is deeply philosophical.
It gets really deep.
It does. The AI points out that by stripping away the mathematical makeup, the coder hasn't just optimized a script. They've arrived at a fundamental realization about the nature of existence.
Wow.
The text lays it out in these stark, brilliant binary statements. It says, no circle, therefore there is motion. No form, therefore there is process.
Process over form, that feels so active, so incredibly alive compared to standard geometry.
Because it is entirely active. Traditionally, you and I were taught that pi is a fixed, static property of a shape. You draw a rigid circle on a piece of paper and boom, pi exists purely because of the physical ratio of the circumference to the diameter.
We're taught that the shape dictates the number. The circle creates pi.
But this source argues the exact opposite reality. Pi is the integral of unit motion. It is the step-by-step accumulation of movement over time.
The circle isn't the source at all.
No, the circle is merely the consequence. It's the trailing visual exhaust of that continuous accumulation of steps.
So let's trace the intellectual journey we just took together. You sat down today to look at a simple Python script. A basic 1 million step loop designed by a coder just to spit out a string of decimals.
Right. Sounded like a normal Tuesday.
But by simply asking why that loop worked, the coder systematically dismantled how mathematics is traditionally taught to millions of people. This text took one of the most famous, revered numbers in human history, violently stripped away its complex pedagogical scaffolding, and redefined it entirely.
It took pi from being a static, dead shape and turned it into an active living process.
Yes. It proved that pi isn't hiding inside a geometric circle waiting to be found by complex algebra. Pi is just the physical act of taking a step over and over again in a constant direction.
It changes pi from a noun into a verb.
Oh, I love that.
It's a staggering shift in perspective. It means that the fundamental building blocks of our reality might not be solid, unchanging shapes, but continuous, ongoing actions.
It is a phenomenal text, blending raw mechanical coding with high-level foundational philosophy. It really forces you to examine the lenses through which you view fundamental truths. Which brings us to a final thought for you to take away today.
We spent this entire deep dive looking at how a continuous, smooth shape, the circle, is actually an illusion created by millions of tiny, discrete, individual steps accumulating one after another.
Right.
If the ultimate symbol of smooth, continuous reality is actually just a Riemann sum of discrete actions, what about time?
Oh, wow.
We perceive time as a smooth, flowing, unbroken river. But if the physical geometry of our universe is built on discrete unit motion, what if time itself is just a Riemann sum? What if it isn't a smooth flow at all, but millions of tiny, discrete, individual flashes of now accumulating step by step, creating the illusion of a continuous timeline?
Just remember that feeling you had at the start of our deep dive today. That unshakable skyscraper of objective truth might just be a pedagogical facade. Sometimes the most profound, universe-altering truths aren't found by climbing the incredibly complex scaffolding of academic theory.
Sometimes you just need a pedometer.
Sometimes the truth is found by simply putting on a pedometer, trusting your own intuition, and taking a single, simple step. We'll catch you next time.